uh, so you can use the toolbox to
Today
do
we're
the
going to talk
classification.
about a very beautiful app inside Math.
So if you are really hurry, and then you can read the video for the classification for your project. Now we discuss we is called lab time. So first I want to summarize your stage one and stage two. I think most of the group, they are very doing a wonderful job, and especially assignment two is really good. I think it's terrific. Uh, so in that group three, for most of the group, I think it's not challenging, but maybe for some group, a little challenging. Um, so I think you need to very carefully select the project. So based on your group uh, expertise, your capability, and then select the project. So the first, I updated the learning guide. I mean, if I go to the learning guide, I think I study guide. I didn't put it to the canvas yet, but I will after you select the project, I will put there uh, subject outline preparation. So the second version, you can basically we have a before we have a five project. So the first one is airflow and the lung volume. This one is actually the smaller version of K4B2. So like this is sometimes use home telecare. So if some people don't want to go to a hospital, and then they can measure the airflow and the lung volume, and then they can send it to the doctor. And here this because we cannot use hardware, so my thinking is like maybe I have a K4B2 data. So the K4B2 data is more information than your airflow and the lung volume. So we have the even inside, we have chemical sensor. We measure your oxygen, measure your carbon dioxide. We give you all the uh, data to you, and you can do whatever you want. You want to model, for example, the VO2 or VCO2, or you can measure heart rate, or you can want to use this heart rate to estimate VO2, VCO2. They're all okay. But the key technique is that today I discussed. One is called dynamic modeling. We only talking about first order, and also another one is static modeling. And also you need to use the system identification toolbox. That one will automatically get the result for you. So this one I don't want to spend too much time for this one. Uh, if you select this one, I will discuss with you after I introduce all the project. And Jeffy will introduce some project, and Kari will introduce some project, and then you can select, and based on we give you maybe 10 minutes, your group have discussion to select which one, and then I will go to individual room to tell to I mean finalize the project. Of course, if you don't want to finalize today, maybe you end of this week you give me actually the earlier the better. We don't have enough too much time to select. Another one, second one is blood pressure. We because we don't have this equipment again, and Jeffrey will introduce. He found someone can we can simulate the blood pressure signal, and then you can use the simulated signal to do signal processing to find what's the systolic and diastolic blood pressure. And because I also put all the reading material to here, you can also go to website to get some basic knowledge about what's the blood pressure, how to measure blood pressure, what's the theory behind. So this is very important, not only just the signal processing. Uh, so that's why in stage three we want to have a before you can see we are not very biomedical, right? You can other signal we can deal with as well. But in stage 3, all our projects is related with biomedical. So the second one is blood pressure one. I will ask Jeffrey to explain later. And also ECG one. The ECG one is also we generated ECG use MATLAB. And then you can use MATLAB to determine, because this is not normal ECG signal. It's have some diseases. Can you use MATLAB classification learner to classify this is a healthy ECG and this is a non-healthy ECG. So also maybe Jeffrey will show you how to generate the the artificial heart rate signal, not heart rate, ECG signal. So if from ECG you can calculate PQRST wave, and then you can, for example, calculate heart rate or RR interval. And then the muscle active fatigue, this is also simulated EMG signal. Before we all have the equipment, but unfortunately we cannot go there. But I think the simulated one, uh, plus your reading, if you're reading lots of other things, and then it will be okay. We still can learn what we want to learn. And for the microcontroller one, actually this part we don't have microcontroller to provide, so we use smartphone based. So I remember in group 2, Leo have demonstrated use a smartphone to monitor exercise. But here actually I will also provide the two option. So I mean you can use either iPhone or use Android phone. So if you use Android phone, so I think I have a free app. You can download free app. But if you use iPhone, you need to maybe spend about $7 to purchase one. So I spent $7 in my iPhone. So I will show you how to use my iPhone to measure exercise. And if I so the last one is EEG based emotion classification. So the EEG based classification is maybe Jo Kari will give explanation. So EEG, they can from EEG can analyze you're happy or not happy, or angry, or things, emotion classification. Very interesting as well. But this signal is also we download, I mean, from the website. So this is a very popular website. Now I give you quickly show. I'm using iPhone to measure acceleration or measure gyroscope signal. So and also for Leo, maybe their group they already have their one, so you can use your method to measure the body movement as well. So you are group 2. Hi Leo. Hello.
Hello, sir.
Hi. So is your group will select the EMG based, I mean the IMU based, the iPhone based project?
We have not decided yet, so
Yeah.
I
Okay.
want to do this
Yeah.
before the group.
Your group 2, I mean group your report I have read is really good. Yeah. Terrific. Yeah.
Thank you,
Uh,
sir.
and also we look at this one. For example, I show you what's the uh, first you need to download. I already show you how to download. It's in the study guide. In the study guide, I mean, if I go to, I put some. So this is original project with microcontroller based. So some microcontroller include accelerometer, TRAX accelerometer, and So, but we use a smartphone-based wearable health monitoring system. So we use you can download if you use Android phone, you can go to here to download sensor stream IMU plus GPS, and then you can uh, find the connection method. So they have an IP address, and then this one you can connect, and then you can start to measure. You set it in your iPhone as well, and then you can start to run your MATLAB. We provide the MATLAB code as well, and then your MATLAB can online read the data, and then you can do all the analysis here and do signal processing, or you do classification. For example, you do fall detection. Can you detect the falling, or can you uh, identify there's some change of access rate or something like that? So it's based on the signal processing and the classification. So now we look at if I go to my computer. Actually, I already installed the MATLAB code. So I need to find MATLAB code. For example, is here. If I run this one, first I need to connect my computer here, my uh, iPhone. I open that, and then you can see I have iPhone. My iPhone, but it's very maybe difficult to read. But actually, I let them running, and then the iPhone when iPhone run, and then I can read the data. You can see the. Can you see the data already? So this is the data, right? So this is my iPhone. If I swing my iPhone, you can see, and the output is doing, and but if we change the location. First, you need to know how to find the axis. See, they have three axes: X, Y, and Z. You need to identify where's X, where's Y, and where's Z, and then you can find. Also, you can identify the uh, head movement. If you do the different head movement, and then you can identify. So this is the one. If you select this one, I will give you the MATLAB code and the things, and then you can, for example, you can do signal processing for this one. If I do signal processing, this is I'm do uh, this is for the gyroscope. For example, you can generate your maximum access rate. So for example, I have done that is around 7 or something. I do this access frequency hertz here. Mostly it's in the 4 to and 5. But like even the fast people in the world, they cannot generate 35 uh, hertz over 35 hertz. So I can only generate around 10 hertz as my maximum I can generate. So in that case, you can get rid of all the frequency over 30 hertz, and this is not related with your exercise or related with your movement. So maybe it's some artifacts. So so this is the signal I measured, just like this is the original signal I measured, and then you can use previous uh, method to analyze. Okay, so this is the first part. I introduced, I think, together with lecture, I introduced the group one, the first project, and the last part, the five, project 5, and maybe I give this one to Kari. Kari maybe introduce the EEG based signal, EEG based emotion classification. Hi, Kari.
Yeah, I'm here.
Yeah, sorry for you let you to wait so long. And yeah, maybe you can give as detail as possible because the student will based on their expertise. If there's a if it's too hard, maybe they will not select. Maybe you give them some confidence, like this
Yeah,
step is hard, not hard, and things. Uh, give some confidence, let them to select the one. And yeah,
yeah, cool.
yeah, thank you.
So,
You want to be the co-host, right?
yeah, can I be the co-host so I can share the
Yeah,
screen?
yeah, yeah, I can.